Hi guys, so back at it again with another video. I've sort of realized that the second challenge question is actually quite difficult. And so I'm going to show you how to do this question, which hopefully will help you understand how to approach doing the second challenge question. So if you would like to attempt this question before I start, just pause the video and have a go. Otherwise, I'm going to get straight into it. Okay, so consider f of x equals x cubed plus 3x squared plus 6x minus 10. Show that f1 equals 0. So the first part is fairly simple, just a warm-up. We simply substitute in 1 for x. We get 1 cubed plus 3 times 1 squared plus 6 times 1 minus 10, which is equal to 1 plus 3 plus 6 minus 10, which is equal to 0. As we needed to show. Part 2, find the first derivative and hence show that the graph has no stationary points. Okay, so for this part, what we want to do is we'll show that f dash of x is equal to 3x squared plus 6x plus 6. Hopefully that's fairly clear to you. And now what we need to demonstrate is that this is that the original function has no stationary points. Now, in order to do that, we need to show that the derivative, so this function, can never equal 0, right? It has no zeros. And what you'll notice is, for this function to have no zeros, the discriminant must be less than 0, if we can remember our knowledge of quadratics. So b squared minus 4ac must be less than 0. And so what we'll sub in is, the discriminant for this equation is equal to 6 squared minus 4 times 3 times 6, which is equal to 36 minus 12 times 6 is 72, which is equal to negative 36, which is quite clearly less than 0. So this derivative is going to have no solution, so the original function will have no stationary points. Now on to part 3, which is the important part, really. And this sort of gets into a bit more of a logical field. Using your answer to part 2, explain why the function can have no solutions other than x equals 1. Right. So there's two ways we can look at this. We can look at this geometrically and graphically, perhaps algebraically. So if we examine the graph of y equals f of x, we know that there's a solution at x equals 1 here. Now, we also know that there's no stationary points. So it's going to cut the y-axis somewhere, we don't really mind where. It's going to wiggle a bit, there's going to be a point of inflection, and then it's just going to continue increasing, right? Now, the reason this is the reason this is an increasing function and not a decreasing function is because the coefficient of x squared is positive, which means that the derivative, this quadratic here, is positive definite, right? So if we were to graph the derivative, so this is y equals f of x, if we were to graph the derivative here, it'd look something like, where's the vertex? I think it's at x equals 1 or something, perhaps here. It's going to look something like this, right? So it's positive definite, it's going to exist above the x-axis. That means that it's the primitive, the cubic here, is an increasing function as opposed to a decreasing function with no stationary points. Now, if this function is always increasing, that means it will never be able to cross the x-axis more than once. So if this function is always going upwards, there's no way it can cross it here and have this solution, and then for it to come back down, it would have to have a stationary point, or for it to come back up from here, it would have to have a stationary point. So the fact that this function is strictly increasing means that there can only be one solution.